by using the size of operator. So first way, so we can calculate by adding the individual sizes. So here size equal to size of pages plus size of name plus size of author, then size of price. Like that, here in manually we have calculated like this. Suppose here 4 plus 10 into 1 plus 10 into 1 plus 4, and then we are calculating like that, 4 plus 10 plus 10 plus 4 means final value is 28. So this is the manually, but in our C programming, here struct, so this is a keyword, and here I am taking the book, this is the name of structure. Okay, then here using these different data types like that, int, pages, then char, name, char, author, and here we are taking this size of that array, and the float, price, and b1. Okay, so this is the, and another way of calculating by using the size of operator. So in that, we are taking like that here hash include stdio.h. So this is the standard input output header file. Then using this type definition here struct b1. Okay. Then char b name 20 int ssn int pages, and this is the book. Okay. After that, we write in that inside the main. So book b1 here I'm initializing like that. Let us see 1090. Okay, so this is the name, book name, let us see, and the here ssn number is that, and how many pages means 90 pages. Here I am storing in that. Then after that, if we want to print out this by using this printf, the size of structure %d, the size of b1, so it will we will get the size of that structure using this size of operator. Okay, then next is that the array of structure. uh, Structure is used to store the information of one particular object, but if we need to store the such 100 objects, then the array of structure is used like that. Here suppose I am taking the structure like that. Here struct is a keyword, and my name of structure is that book info. So then char book name here, the size of that v name. Okay, then int pages, int price, after that book 100. So here book structure is used to store the information of one book. In case if we need to store the information of 100 books, then array of structure is used. Means here we are putting b10 store the information of first book, b11 store the information of second book, and so on. So we can store the information of 100 books like that. Means array index start from 0. So like that, book 0, book 1, book 2. Particularly we are storing that information in that array of structure. Okay, getting it? Yes or no? Then next is the nested structure. So structure written inside the another structure, so is called as the nesting of the structure. So we can write one structure inside the another structure as a member of another structure. So in that, first way is that declare the two separate structure. Okay, so see in that struct date and struct employee. Okay, here structure member are accessed using the dot operator. Okay, and date structure is nested within the employee structure. So here this is the date structure, and it is nested to the this employee structure. So member of the date can be accessed using employee. So emp1 and object are two structure names variables. So accessing month field like that, here employee 1 and doj say dot month, accessing day field employee 1 dot date day, then accessing year field employee 1 dot doj dot year. So by using this, so structure written the inside another structure, so is called as the nesting of two structure, and then we can write the one structure inside another structure as the member of the another structure. So this is the example of that nested structure. Okay, getting it? Yes or no? Then another way, second way is that so we have to take the nested structure, declare the embedded structure. Means structure member are accessed using the dot operator. So here I am having two structure like the struct employee and the struct date. Okay. So date structure is nested within the employee structure. Okay. Then here EMP1 and DOJ are two structure names. Okay. These DOJ and EMP1. So these are the two structure names variables. So as first in that we are assessing the month field by using this EMP1 dot DOJ dot month. Okay. Whenever we are assessing the month field like that EMP1 dot DOJ dot month and assessing the day field like that here EMP1 dot DOG day means EMP1 dot DOJ dot day. Okay, like that. Assessing year field EMP1 dot DOJ dot year. Okay, so this is the declaration of embedded structure. Then the passing the structure to the function. So there are mainly two ways to pass the structure to the function: passing by value and the passing by reference. Okay. So first we see the passing the structure by value. A structure variable can assist passed to the function as an argument or as a normal variable. If structure is passed by value, change made to the structure variable inside the function and definition does not reflect in the originally passed structure variable. So function prototype should be below to the structure declaration, otherwise compiler uh, shows the errors. Okay. So here passing structure by value hash input stdio.h. So this is the standard input output header file. So struct is a keyword and student is my name of structure. Okay. In that we are taking this char data type and int data type and name. This is the first field and marks another field. Means we are using these two different data types in that. So here we have to declare this structure. Then we are taking the passing structure by value. So here void display struct student stud. So function prototype should be below the structure declaration. Otherwise compiler shows error. Okay. Here we are using this function prototype. Then int main. After that here I am taking this struct student stud. Okay. Then using this printf function, enter the student's name. Okay. So here we want to display the message on our output screen. So using this printf function, so we are taking enter the student name. Then we can using the scanf here percentage is ampersand student dot name. Here we are using this dot operator to access that the field name. Okay, then printf enter the marks, then scanf percent d ampersand stud dot marks, then display the stud. Here we have to display here displaying the informations of that stud. Then printf marks after calling the function stud dot marks. Then here void display struct student stud. Then printf output name percent is stud dot name stud dot marks, that is equal to stud dot marks plus 10 printf roll number percent is stud dot marks. So this is the passing structure by value. Okay, getting it? Yes or no? Hello. Okay. Then next is that the passing structure by reference. So in that the memory address of a structure variable is passed to the function while passing it by reference. If structure is passed by reference, changes made to the structure variable inside the function definition reflects in the originally passed structure variable. So use the same concept of passing an address and receiving it in the pointer variable in the called function. So like that, this is the example of the passing structure by the reference. So here void add struct distance d1, struct distance d2, then struct distance into d3. So here we are taking like that struct distance dist1, distance 2, distance 3. Okay. So using this printf function, first distance, enter the feet by using the scanf function percent %d ampersand dist1 dot feet, then enter the inch scanf percent %f ampersand distance 1 dot inch, second distance, then enter the feet scanf percent %d ampersand distance 2 dot feet, then printf, enter the inch, then scanf percent %f ampersand distance 2 dot inch, add distance 1 comma distance 2 ampersand distance 3. So here the passing structure variable distance 1 and distance 2 by the value, whereas the passing structure variable distance 3 by the reference. Okay. So here printf some of the distances percent %d percent %1 f distance 3 dot feet distance 3 dot inch. Then void add struct distance d1, struct distance d2, struct distance into d3. So here we are assessing the data by using that adding the distances d1 and d2 and showing it in the d3 like that. Here d3 feet is equal to d1 dot feet plus d2 dot feet, means we are adding the distances d1 and d2 and storing it in the d3. Okay, then d3 inch is equal to d1 dot inch plus d2 dot inch. So here we are taking the if inch is greater or equal to the 12, converting it to be feet. So here we are taking this if here d3 inch is greater than or equal to 12, means if inch is greater or equal to the 12, so we are converting it to the feet. Okay, so here uh, passing structure by the reference. So in this program, the structure variable distance 1 and distance 2 are the passed value to the add function, because the value of distance 1 and distance 2 does not need to be the display in a main function. Okay, and but distance 3 is passed by reference, that is the address of distance 3 ampersand distance 3 is a passed as a argument here like that. We are using this in that function, so passing the structure variable here like that by using this ampersand distance 3, means uh, distance 3 is a passed by reference, that is the address of distance 3 ampersand distance 3 is passed as an argument. So due to this, the structure pointer variable d3 inside the add function points to the address of a distance 3 from the calling main function. So any change made to the d3 variable is seen in the distance 3 variable in main function. So as a result, the correct sum is displayed in the output. Okay, are you getting this? Yes or no? So now we'll see the example of assessing the structure members, okay, in our C program, okay. This is visible? Hello?
Yes, sir.
So as earlier told, the assessing the members of the structure. So members of the structure, that is a variable declared in a structure, can be assessed using period or a member of assessor, means we are using the dot operator, okay. So any member of structure can be assessed structure variable name and the member names, okay. So in that we are assessing the structure members. So here, first is that the hash include stdio.h. So this is the standard input output header file. Then hash include string.h. Here I am taking this struct. This is a keyword, and this is student is the name of my structure. So in that, we are taking using this different data type char, int, again char. In that first name, age, and branch. Okay. Then here char gender, uh, F for female and male for M for male. Okay, so here we are declaring this structure. Then int main, again here struct student S1. So here S1 is a variable of student uh, type, and age is the member of student. Okay, here I am taking this S1 dot age, that is equal to 18. So using the string function to add the name, here I'm using this strcpy s1 dot name, like that. Here we are taking any name. Suppose I'm taking here like that, Nirma. Okay. Then the displaying the stored values, like that. Here we are taking the student name. Okay. Suppose I'm taking here Ramesh. Okay. So displaying the record values, like that, printf name of student one %s dot name, means we are using this dot operator to assess the structure members variables. Means here we are taking these are the member one, member two, and member three. Okay. So we are assessing by using this dot operator. So printf name of the student one %s1 dot name, and printf age of that student, like that, s1 dot age, and then return 0. Okay, so we are executing this. Output window visible or not? So like that. So our output will be name of student, like that, this, and age of the student 18. Getting it? Yes or no? Hello? Getting it or not? Okay. Next example, we'll see the array of structure. So in that array of structure, so structure is to store the information of one particular object. Okay, so like that we are storing the information. So this is visible. Yes. So here the example of array of structure. So in that I am taking the structure employee. So first here hash input stdio.h. So this is a standard input output header file. Struct, so this is a keyword, and employee, this is the name of my structure. In that I am taking two fields like that, e name here 10, int salary. Then I want to display the uh, struct employee emp5. So employee of uh, size 5. So in that emp is of type of uh, employee, like that here struct employee emp5. Okay, this is the size of that employee structure. Then int I comma j, these are the two variable. Then I am taking this void ask function here. Okay, then using this for loop for I is equal to 0, then I is less than 3, semicolon, then I plus plus. Okay, here I am storing the data for 3 employee. Here printf enter the %d first employee record slash n I plus 1, then printf employee name slash t, then scanf %s employee I dot e name, then printf enter the salary, then scanf %d ampersand employee I dot salary. So printf displaying the employee record by using this for loop for I is equal to 0, I is less than 3, I plus plus. Then here printf employee name is %s, comma employee I dot e name, and then printf salary is %d employee I dot salary. Then void main, and here I was using this function ask. So we are using this array of structure. So we'll see the output of that. Output window visible or not? Hello?
Yes, sir.
Okay. So here enter the first employee record. Suppose I am entering here Ramesh. Okay. Then enter the salary. Okay, like that here I'm entering the salary. Then enter the second employee record. Suppose I'm entering here Rohit. Okay. Then enter the salary like that. Enter the employee third record. So we are taking here, suppose here. Okay. And then storing this, and it will display us the employee name. First employee name is that this, salary is this, employee name second, salary this, employee name third. So this is the example of array of structure. Getting it or not?
Yes, sir.
Okay. In structure, and next point will be there, structure and pointer. Then accessing the structure member through the pointer, then pointer to array of structure. We have seen that. Then pointer to array of structure. Okay. So this, whenever we'll see the pointer, after that we will see these 2-3 points, structure and pointer. Then the accessing structure member through the pointer, then accessing the structure member through the pointer, then the pointer to array of structure, then pointer to array of structures. Okay. Before that, we'll see the pointer. Okay. Because of when we see the pointer, then we'll see these examples. Okay. So I'm giving the introduction of pointer. So pointer is
So have you shared your screen?
Hello? No.
Okay, yes.
Without screen, I am introducing you a pointer. Okay. Then after that, we'll see the using the structure pointer. Okay. First of all, introduction to pointer. In that, a pointer in C language is a variable, so which holds the address of another variable of the same data type. Okay, and then the pointers are used to access the memory and manipulate the address. And the pointers are the one of the most distinct to existing the features of C language. So it provides the power and flexibility to the language. Although the pointers may appear a little confusing and complicated in the beginning, but trust me, once you understand the concept, you will able to do so much more with the C language. Before we start understanding what the pointers are and what they can do, let's start by the understanding what does the address of memory location means. Whenever a variable is defined in C language, a memory location is assigned for it. So in which its value will be stored. So we can easily check this memory address using the ampersand symbol. If var is the name of the variable, then ampersand var will give its the address. Okay. So I'm sharing the PPT. Wait. This is visible? Yes or no? Okay. So pointer is a variable, so that store the address of another variable. So it is a derived data type in C programming. Visible? Okay. So it is a built from the fundamental data types, a variable name directly reference value. So a pointer variable must be declared before it can be used. So each memory cell in the computer has an address. So that can be used to access that location. So a pointer variable points to the memory location, so we can access the change the content of this memory location via the pointers. Okay. So pointer is a variable, so that store the points to the address of another variable. In C, pointer used to allocate the memory dynamically, so that is at the runtime. Suppose we are taking the variable name like that I, J, K, okay, and then the value of that variable like that 3 is 1 is 1, okay, and address location of that variable like that 65524 6552 22 and 65520, okay. So it is I is the name given for particular memory location of that ordinary variable. Let us consider, so it is the corresponding address B65524 and the value of stored in variable I is 3. The address of the variable I is stored in another integer variable whose name is J and which is having the corresponding address like that here 65522. So reference pointer ampersand. So if var is a variable, then ampersand var is the address in the memory. Like that, j is equal to ampersand I. So that is j is equal to address of I. Okay. Suppose here variable name I, that variable value is 5 and variable address is that 65524, and then next is the name variable name j, then 65524, this is the variable value, and 565522, this is the variable address. Okay, then the declaration of the pointer. So we are using that whenever we have to take the pointer, so declaration of the pointer. So here dereference pointer, so in that we are using that asterisk symbol are used for defining the pointer variable. Suppose here data type and the asterisk Then pointer variable name means here I'm taking integer. So this is a data type. This is an asterisk sign. And pointer p. So p as a pointer variable of type integer. Okay. And then next is the ampersand symbol is used to get the address of that variable, and asterisk symbol is used to get the value of the variable that the pointer is pointing to. So this is known as the indirection operator or dereferencing operator. So it is unary operator. So for example, I'm taking here int main, after that int pc. So here pc as a pointer variable of type int, then another is that int c, then here I'm initializing c is equal to 22 by using the printf function. So I want to display here address of c %d ampersand c, and the printf value of c %d /n/n c. Okay, so these are the different two. Means here we are using pc is equal to ampersand c. Means here we are using this printf address of pointer pc, like that here, comma pc, and then the content of the pointer pc %d, comma here pointer variable pc. Then c is equal to 11. Then next is that printf address of pointer pc, here pc, then content of pointer pc, here pointer variable pc, and another like that here pointer pc is equal to 2, then printf address of c ampersand c, printf value of c. Then here we are seeing that address of c is like this, and the value of c is the 22. So here first like that c, we are initializing c is equal to 22. Then after that address of pointer pc is like that, and the content of pointer pc means here we are taking this content of pointer pc is a pointer variable pc, so like that 22. Then next address of pointer pc is here, and content of pointer pc is 11, and address of c is like that, and value of c is 2. Means first pc is here, then we are declaring here pc as a pointer variable of type integer, like that here we are using that asterisk pc and c. After that next line 5 c is equal to 22. Here we are storing that value in that particular memory, and then again line number 8. So pc 8 pc is equal to ampersand c, means we are storing that address of that particular variable of c. Then line number 11, so we are initializing the c is equal to 11, and that 11 we have to store in that c particular memory location, and like that here this line number 14, so pointer p is equal to that point, to that the address of that, and value of c is 2. So this is the dereferencing pointers. Then next point is that the computer memory revisited. Computers store the data in memory slot. So each slot has a unique address, and variables store their values like this. Suppose I am having this address 100, and the content is that I:37, then 1001, after that 104, 108. So a of 0 like that, ptr like that. The next address are 101, 105, 109, and these are the contents like that. Okay. Then altering the value of variable is indeed the changing the content of the memory. So like that, for example here I'm taking this I is equal to 40, a of 2 is equal to z. First is this is the address I is colon 40. These are the content, and A2 is equal to Z. Okay, this is the same. These are address like that. Okay. Then the addressing concept. Pointer store the address of another entity like that. It refers to the memory location. So here I'm taking this integer data type and initialize this variable I is equal to 5. Okay. Then next is the pointer variable followed by its integer data type pointer ptr. So declare a pointer variable. Okay, like that, and ptr is equal to %i, so it store the address of I to the pointer, and here printf pointer variable ptr, that is equal to %d, and pointer refer to the referee of ptr. So this is the address concept. And what actually ptr is? So ptr is available storing an address. ptr is not storing the actual value of I. So like that, here int I is equal to 5. Okay, we are initializing this value of that I variable, that is 5. Then int pointer ptr. So printf I is equal to %d of I, and printf pointer ptr is equal to %d pointer, here ptr address of I, like that, value is 5. Okay, and printf ptr is like that, this. Okay, I is equal to 5, pointer 5, and ptr like that. Value of ptr address of I in memory, that is the ptr is equal to EFF. Okay, getting it? So we see the example of this is visible, yes or no? Okay, so in that using the pointer or dereferencing of a pointer. Okay, So we'll see the example of that. First is that hash input stdio.h, then int main function. So every program starts its main function. So first here int a comma pointer variable p. So here we are declaring the variables and pointers. After that, initializing a is equal to 10 and then the p is equal to ampersand a, means we are initializing the pointer to that p variable. Okay. Then next is printf %d/n pointer variable p. So this will print the value of a. Okay. And then next is printf %d s here pointer, then ampersand a. So this will also print the value of a. Then printf %u, then ampersand a. So this will print the address of that variable a. And then next is printf %u p. So this will also print the address of a. And printf here %u ampersand p. So this will print the address of p. So this is the pointer of dereferencing of the pointer. So now we'll see the output of that. So like this, okay. 10 means we are printing the value of a first, okay. Then second, in that second we are using the asterisk and ampersand a. So this also the print the value of a. Okay, we have initialized that a variable. After that, third is that we are taking the ampersand a, means so this will print the address of a. Then next thing is that in first we are initializing the p is equal to ampersand a. So that's why again it's print the address of that a variable. And then next is that the ampersand p, means this is the again print the address of p. Okay. So this is the example of using the pointer or dereferencing of the pointer. Getting it or not? Hello? Okay, so today we stop here. Please leave the class now. Yes.